we can get some good information about a system by raising its transition matrix to various powers. I'll show you an example. Let's take that 1960s women working and not working transition matrix. We've got that here. So, you know, what we've got now is this transition matrix is really to the first power, right? That's really to the first power. And what it says is, if a woman is currently working, in the next generation, her daughter, there's an 80% chance that she'll be working. Or if you like, out of all the working women, 80% of their daughters will be working. And out of all the working women, 20% of their daughters will not be working. Now I'm going to square this matrix. So if I square this matrix, now I did this on Wolfram Alpha and my calculator. So here's what I got. I'm reading down the first column. I got 0.70, 0.30, and then I got 0.45, 0.55. I'm going to do it one more time. Let's cube this thing. So if I cube it, let's see, what do we get here? All right, I'm getting 0.65 down the columns, 0.35, and then 0.525, and 0.475. This is enough for us to get the idea of what's going on. So here's what this is going to tell us. Let's go through each one of these. This first one is to the first power, and this is for one generation, from one generation to the next. So if a woman is working, there's an 80% chance the next generation, her daughter, will be working. Now, I'm not going to prove it, but in a minute I'll give a justification for it. This is squared. So in the second generation, 2 generations, right, what's the probability of going from W to W in 2 generations? That's going to be 70%. So this, if a woman is working, what's the probability that her granddaughter will be working? That's a 70% chance. If a woman's working, what's the probability that 2 generations later, that means her granddaughter will not be working? 30%. And you're probably getting the idea now. If we cube this, this would be 3 generations later, so this would be great-granddaughter. So if a woman is working, probability that her great-granddaughter will be working, 65%. I'm going to summarize this. T to the first, this is the probability. This T to the first gives the probabilities of going from one state to any other state, maybe even the same state, but probably of going from one state to some other state in one transition. And T squared, right, to the second power, this is the probability of going from one state to some other state in 2 transitions. And you're probably getting the idea now. What about T to the third power? Those entries are going to give the probabilities, those entries in T cubed will be the probabilities of going from one state to some other state in 3 transitions. And now we're going to generalize it because mathematicians like to generalize things. But if we raise T to some power n, where n is a counting number, 1, 2, 3, 4, and so on, all right, that's going to give us, those entries will be the probabilities of going from one state to any other state in n transitions. So for example, if we take our matrix that we were working with and raise it to the 4th power, we get these entries, and what does it mean? Well, it means these are probabilities of going from one state to another state in 4 transitions. So what's the probability of going from women working to 4 generations later, that great-great-granddaughter working? That's this number here. If you want to follow along now, I'm just going to make a suggestion as to why this works. And I'm going to do it by means of a transition diagram. So we have 2 states. We have working and not working. And by our transition matrix, if we're at working, the probability in one transition of still working is 0.80, and of not working is 0.20. And then if we're here where we're not working, the probability of not working again, all right, that's going to be 0.70. And if we're not working, the next generation, there's a 30% chance of going to working. Now, that's going to be T1, right? This diagram would work for T1. Now, what about T2? What if we want to do this? We want to go from working to working in 2 transitions. Let's see how we can do it. Well, here's what we could do. We could go working to working, and then to working again. That makes sense? I'm going to come over here. If we're in working, how can we get back to working in 2 generations? We could go working, remain in working, and then again, working to working. Now, here's what these numbers are going to be, right? Going working to working, that's 0.80, and working to working again is 0.80. So we're going to go here and here, so I'm going to multiply those. So that's going to give us 0.80 times 0.80, which is 0.64. Now I could have done this. I could, if I start here at working, how do I get back to working in 2 transitions? I could have gone from working to not working, and then not working to working. So let me write that. We could have gone here, working to not working, and then from not working to working. So working to not working, that's a 20% chance that that's going to happen. And then, right, working to not working, 0.2, and then not working back to working is going to be a 0.3. So I want to go here and times here. So this is going to give us a 0.20 times a 0.30, which is a 0.06. And now I'm trying to get, right, where are we trying to go? We're trying to go from working to working in 2 transitions. So we could do it this way, working to working to working, or, and or we know as a plus, we could go working to not working, back to working. All right, so I'm going to add these numbers together, and if I add those together, I get 0.70. And if you look at our original transition matrix and square it, what do you get? Working to working in 2 transitions is 0.70, and that's what we developed up here. Now we could get the same numbers going the other way. We won't do all of these, but how could you get from not working to, say, not working to working in 2 transitions? I'll just map it. So you could go, right, well, what could we do? I'm going to bring it up here. I'm going to start at not working. How can you get to working in 2 transitions? Well, what you could do is this. You could go from not working to working, and then working to working. So if I listed those, it would be, okay, I start at not working, we go to working, and then we go to working again. Or you could go to not working, back to not working, and then to working. Right? The first one is this one. You're not working, you go to working, and then you remain in working. 2 transitions. Or, plus, you go, you're not working, so you go back to not working in the next generation, but then the second generation, you go to working. That's what these are. So you could find those numbers, and I claim that you're going to get, right, what are we doing? Not working to working, 0.45.